Hello guys, and in today's tutorial we'll be looking at loop. Okay, so what is a loop? A loop is a control structure, okay, that repeats a block of code for each element multiple times. Okay, so it could be sequences of numbers, it could be characters or items in a vector. Okay, basically it is trying to iterate, okay, over the same task, sorry, several times. Okay, so in R there are basically three forms, okay, of writing a loop. We have the for, the repeat, and the while. Okay, but for today's tutorial I would deal much with the for loop, and then hopefully in the next tutorial we'll look at the repeat and the while, and then you decide for yourself which one you would want to go with. Okay, so we'll start with the for loop. Okay, so the the syntax for the for loop, okay, is basically you key in the for, okay, and then in the suggestion window given, when you tap on it, this is the basic syntax for the for loop. Okay, this is the basic syntax. So it says for variable in vector, and then over here is the block of code to be executed multiple times. Okay, so this is the basic syntax for the for loop. Okay, so I'm going to take this tutorial step by step. We're going to deal with one particular problem, okay, and then with that problem we'll build on to the for loop. Okay, yeah, I think if I should do that you would have a better understanding of how to use the for loop. Okay, so let's start. Let's say uh, let's create a database, or let's create a data frame, okay, that has, let's say, students name and um, their scores, let's say their exam scores. Okay, so let's simulate data for 200 students and 200 scores for each student. Okay, as each score for a student. Okay, so let's do that. So we have we're creating the vector to first store the names of students. Okay, so I said 200. So since we need 200 names, we could use the paste function. Okay, and actually I'm supposed to get, let's say, actual names of students. Okay, but that is not much important. We can just simulate one, just like I'm doing now. So we'll use the paste function to simulate student names. Okay, so student, okay, and we're going to simulate 1 to 200. Okay, and we're going to separate it with, let's say, an underscore. Okay, we'll separate it by an underscore. Okay, so the moment I run this, our 200 students have been generated. So if I print student, okay, and I run, you see in the console we have 200 students. Okay, we said we wanted to paste student, and the separator should be an underscore, which you can see here, and we running it from 1 to 200. So you have students 1, 2, 3, up to 200. Good. Now let's so let me just put the comment here. Let's say simulating. We simulated sorry, we simulated students. Let's say student names. Okay, so over here we simulated student names. Now the next thing we're going to do is going to be to simulate scores scores for each student. Okay, so to simulate scores for each student, we could use the sample function. Okay, so let's create an object called scores, and that object is going to store the scores of the students. Okay, so if we call the sample function and hit the tab key, we are supposed to fill in these arguments. Okay, the argument x is actually the data or the vector from which the sampling is going to be made. So in this, or the data we're going to use, okay, or the scores we are going to consider, the range of values we are going to consider is going to be from 40 through to 100. Okay, though we don't expect a student to score 100 over 100, but it is possible. Okay, yeah. And then we take in the next argument. It says the size. Okay, so the size we are expecting is 200 because we have 200 students. Okay, and we're going to set replace to true, so that each time a sampling, or yeah, so that each time a sample is taken, the value from that sample is replaced. Okay, because looking at the data size, we have 40 to 100 and we are considering a size of 200. The data won't suffice the size we are looking at, so we need to set replace to true. I have explained this in the previous videos. Okay, so once we run this and we print um, scores, you can see that we now have the student's score simulated. Okay, so now let's knit this together in a data frame. Let's create a data frame and knit this together. So we're going to call the object to store the two vectors as students data, and we're creating a data frame, okay, to store those vectors. So we're storing the vector student and the vector score. Okay, so when we run this, we have it created in the environment. It has been stored in ours memory. So when we print the student data, okay, you can see here that in the console you can see that we have our students and their scores. Okay, we have our students and their scores in a tabular form. Okay, good. So it's important to leave comments. So here we created a data frame to store the vectors. I'll just put it this way. Good. So we've seen this, right? We've created a data frame. So assuming you are being taxed, okay, that you have these students, you have these scores, and you are to grade them. There is a grading scheme, okay, that you are going to use to grade these students, okay, and you have about 200 students. How are you going to go about it? Okay, how are you going to go about it? We're going to do it the manual way first, and then we're going to see how important for a for loop or a loop is to help make things faster. Okay, so the task here, let me put it here. Our task right now, our task is to grade the students. Okay, that is our task, is to grade the students. Okay, good. Now let's come up with the grading system. Let's say the grading system or the grading scheme to use, any of them, okay, is that if a student scores 40 to, let's say, 50, okay, it is equal to a pass. Now if a student scores, let's say 51 to 60, okay, it is equal to, let's say, good. And then when a student scores, let's say 61 to 70, I would say very good, very good. And then when a student scores, let me just extend this a bit. And then when a student scores, let's say 71 to 100, it is equal to excellent. Okay, so this is the grading system we're going to use, and we need to grade these students. Okay, we need to grade these students. Okay, all right. So now, if we are to grade a student, it means that we need a column to store the grades. Okay, we need to create a column that will store the grades, of the students. Okay, so let's create a column called grade. Okay, so we'll say here that, let's say, column to store grades. Okay, so now we need to create a column, like I said. So we're going to call the student data and use the $sign, okay, and then create the new column. Okay, basically we are creating a new column, and that column is a vector. Okay, because we had two vectors, we needed them together, and we created a data frame. So what we are actually doing is just trying to knit one more vector into the data frame to give us three columns. Okay, so the column is going to be called grade or grades. Okay, and in that column it's going to store characters. Okay, characters, because the value for each of the grading system are just characters. Okay, so good, very good, excellent, they are basically characters. Okay, so if we should take the arguments here, we need to define the length, okay, of the vector. I remember, when you put in vectors together to form a data frame, they must be of the same length. Okay, it means that the empty column we are going to create, or the empty vector we are creating to store the grades, must have the same length as the other vectors. Okay, and because of that, we know that the total number of elements in each vector is what, 200. Okay, so we could either define it as 200, okay, or we could say, assuming we do not know the number of students, okay, or the number of elements in that particular vector, we could say the number of row of the student data. Okay, now if I just run this, observe the console, it tells me the number of rows in students data. So it says 200, exactly like we were suggesting earlier. Okay, but this is more safer, assuming you do not know the number of rows you are dealing with. Okay, so now we can run this, and when we print, okay, when we print student data, okay, you can now see in the console that we have an additional column called grades, the grades column. Okay, now the grades column is basically going to store the grades of the student. Okay, now if we were to do this, so now let's grade the student. So grading, or let's say assigning grades to students. Okay, remember that is our task. Okay, so if we were to assign grades to students, the best thing to do would have been to use the if and else statements. Okay, now let's say though our task is to grade all the students, okay, if I should ask you guys to just grade, let's say row 1, okay, just grade student 1, and assuming we do not know that student 1's value is 87, it means that we're going to write an if and else statement that is going to encompass all these grades, right? Good. So to do that, okay, to manually grade, let's say student 1, okay, we need to start with the if and else statement. So we're going to go if, okay, what is the first sorry, what is the first thing we are looking at? Okay, we are grading the scores. That's the scores we are looking at. Okay, so we can say if from the student data, okay, if from the student data the column called scores, okay, the column called scores, and we, like I said, we are looking to grade student 1, and student 1 is at row 1 or index 1. Okay, so at the column called scores, fetch, okay, position 1. If I should just run this, okay, over here the score is what, 87. So if I should just run this, I'm expecting to see 87, and as you can see, 87 is there. Okay, all right, so now that is what we're going to do. We said we want to grade the student 1, isn't it? Yeah. So like I said, in the student data, the column called scores, the first element, okay, or the first value, which is 87, and assuming we do not know it's 87, then we are just saying the first value. Yeah, okay, so if that value is greater than or equal to 40, okay, and sorry, and the ampersand, okay, and that same student data 1, okay, the column called scores subset position 1, okay, is less than or equal to 50, okay, what should be done to okay, to it? That means that if we check and index 1 is greater than or equal to 40 and less than or equal to 50, what should we do? That is the block of code we need to enter here. Okay, so what we want to do is that we want to subset what, the column for grades. So we are going to say call from the student data, call the column called grades, okay, and subset index 1, because student 1 was from an index of 1, okay, and that is its score is what we have checked. Now if its score fits this, it means that we need to store, or we need to grade it and store that grade in the grade column, and it has to be in line with what, the exact number, okay, the exact score, and that exact score is our what, row what, 1. So that is why we are also bringing 1 here. Okay, and what do we want to do? We want to assign from the grades. It says you should assign what, pass. Okay, it says assign pass to it. Is that okay? Now if the score is not equal to, or if the score doesn't fall between the range of 40 and 50, okay, it means that we need to add another condition. Okay, so we'll bring the else if. So else if, okay, else if the student score, okay, is not falls within the range of the second grading system, then it means that we're going to assign what, good. So I don't want to type all these things because I'm supposed to type, literally I'm supposed to type the whole of this. Okay, so I'm just going to copy this, okay, and paste it here, and I'm only going to make changes to the score now. Okay, so if it is greater than or equal to 51 and less than or equal to what, 60, okay, what should be done? So the same thing here, we're going to just copy this and paste it here, but then this time the value is going to change. The value is actually going to be what? Good, because that is what we the marking scheme or the grading system says. Okay, so good. Now let me just pull this grading system here. Since we are moving away from it, it becomes very easy for us to know what we are about. Okay, yeah. Okay, so we've dealt with that. It is good. Okay, we have that. Now the next category to look at is 61 to 70, which is very good. Okay, so I'm basically going to do the same thing. I'm just going to copy from here, okay, and call the next else if statement. So I'm going to say else, okay, else if, sorry, else if, okay, that, okay, else if that, and then we're going to change here is going to now be 61, okay, and less than or equal to what? 70, okay. And if it falls between that range, what should we do? We should still call the column called great, okay, and then this time we're not going to store good, we're going to store what? Very good. Sorry, we're going to store very good. Okay, good. We're going to store very good, and then finally if, okay, and then finally else if the student data, if the student data, okay, the column called scores, okay, position 1 or value 1, okay, is greater than or equal to what? 71, meaning 71 and above. Okay, so we don't really need to set the range. Okay, in that case, what should we do? We should call the student grade. Okay, so student grade, and then this time around we're going to input what there? Excellent. So put excellent in there. Okay, so now we're done. We're just dealing, remember we were just dealing with the first row. Okay, so the moment I run this, observe the console. When I call students data, okay, and I run, when I call student data and I run, if you check the console, you could see that row 1 has what? Excellent. Okay, row 1 has excellent because 87 is greater than what? 71, and because of that we were supposed to allocate what? Excellent. Now having done this, this is going to be tedious because we have 200 students, okay, and does it mean that for each 200 student we need to come and be changing to, okay, if I need to go to row 2 or the second student I need to change the index and everything? No, that's going to be very tiresome. Okay, so that is where the for loop comes in. Okay, so the for loop makes things very easy. I mean very easy. Okay, we could grade a student in microseconds. Okay, so to do that, we've already seen the syntax for loop. Okay, it says for variable in vector. Okay, so over here you can let your variable stand for anything, maybe an x, a y, a z, a word, whatever you want it to be. Okay, so over here I'm going to let my variable be I. Okay, and then it's saying for I in vector. Okay, for I in vector, it means that I is going to actually take it's going to actually substitute or be substituted for each element in that particular vector. Okay, so in this example where we're looking at we have a data frame for the column for students, scores, grades, okay, we are basically dealing with what? The scores of the students, okay. So we're going to say for I in, okay, basically going to deal with this, the scores of students, okay. So to do that, we need to really define what I is going to be, okay. If we should just put, let's say for I in, let's say student, sorry, let me not type here. If we should put for I in students, if we should put for I in students data subset scores, okay, it means that I, if I is in this, let me just run this. I need to make sure you get this, okay, because that is the key thing to using a for loop, okay. So since this is the variable, it means that I can take place of what? 87. It could take place of 59. It could take place of 79. It could take place of what? 42. It could take place of what? 68. Is that okay? But if we should use this, or if we should use this syntax for I in scores, okay, data subset scores, it's not really going to help, because we have a data frame that has rows and columns, okay, and we are manipulating it based on rows and columns. So it is expedient for us to rather index them, okay, to rather index them. So instead of we using the actual values, okay, the actual values, we're going to rather index, okay. So in indexing, we need to know the number of rows we have. Now the number of rows we have is 200, okay. So if I want to define this, I would have said for I in 1 to 200, or I could say for I in 1 to the length of, let's say, student data subset scores, okay. And I could easily say, okay, for I in seclen, okay, seclen, then the number of rows, and the number of rows of what? The number of rows of the data frame, that is student data, okay. So what a seclen function does is just like sequence, the sec function, okay, that sequences, that gives you the flexibility to um, to uh, state where the start point is, where the end point is, and what difference is going to be between each numbers. The seclen just sequences numbers throughout, okay. And when it's sequencing numbers, it doesn't really need you to define the positions, okay. What it requires you most of the times is for you to tell it the total number you are trying to sequence, okay. So let's say if I want to sequence from 1 to 200, I could just call the seclen function and just type 200. And if you observe the console, I now have 200 numbers being sequenced. So it's the same thing. So either seclen, number of rows of, and then the student data, or you could go for I in 1 to the length of that, or you could go for I in 1 to 200. That's the same thing, okay. So we've defined what I is going to be, meaning that I is now going to take the position of what? 1 or 2 or 3 or 4 or 5, etc. And this is really going to make it easy, because the rows and columns we are dealing with have position indexes, okay. We have row 1, row 2, row 3, and it matches with this, okay. So it's going to make subsetting columns and rows easier than compared to using the actual values, okay. That was when we did I in student data subset scores, okay. So now that we've defined I to take any of these positions, okay, now we need to work on the block of code. What must be done in the block of code? So this is easy. Since we have been able to analyze for one particular student, okay, one particular student, let me use the head function here to just pull out the first few rows of the student's data. Okay, we just analyze for only row 1. Okay, analyzing for or grading the rest of the students is going to be very easy. Now watch this. All we need to do is to copy our if and else statements from the first to the end, come to our for loop, okay, and basically paste this there. Okay, we need to just paste this there. Okay, now since I is now going to take the values of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, etc., it means that the little the strict indexing we did here, which was 1, 1, 1, 1, we need to change everything to what I. Okay, so that it would execute. When it's done executing for row 1, it moves on to row 2, row 3, row 4 till it gets to 200. Okay, so here is also going to be I, here is also going to be I, here I, here I, here is also going to be I, here is also going to be I, here is also going to be I, and here is also going to be I, here is also going to be I, and here is also going to be I. Now I have this broken thing here, so I need to just fix it. I think I mistakenly deleted it. Okay, so now this is it. We're done. Okay, now the moment I run this, we're good to go. R is done grading the students. So when I call students data and I run it, now you can check and see that all the students have been graded easily. Okay, all the students have been graded easily. Let us view it in a more appreciable format. So view, we're going to use a view function, view student data, and we run. Now this is it. This is it. Everything has been graded very well. Okay, we said if it is between the range of 71 to 100 is excellent. So you could see that it has been graded easily. It didn't take our much time to do this. And that is the importance of for loop, because we were going to repeat the same block of code over and over for the same number of elements. Okay, but the for loop makes it this easy. Okay, all right. So this is one way of doing it. There's I don't know. Maybe we could take another example. Let's take another example. Let's create an empty data frame. Okay, so we're going to create an empty data frame. So empty data frame, I'll say empty df, and I'm going to call it from as dot data dot frame and wrap it in a matrix. Okay, call the matrix function, and I'll set the number of rows to, let's say, 10, and the number of columns I'm going to set it to, let's say, 5. Okay, to 5. Good. So here we've created our empty data frame, right? We've created our empty data frame. There's nothing actually here. There's nothing here. It's empty. Okay, now let's name the column names and row names. Okay, let's say for the column names, we are going to have marker 1, marker 2, marker 3, marker 4. Okay, and for the row names, we are going to have, let's say, backcross 1, backcross 2, backcross 3, up to the end. Okay, so we're going to call the column names function. We're going to call names of empty df. Okay, empty df. And what names are we going to assign to it? So we're going to paste. Okay, we're going to paste, let's say, I said it's going to be marker 1, right? So marker, and we're going to make it from, we're going to make it from 1 to 5, because the number of columns we have is just 5. Okay, and we could include a separator. The separator is going to be, let's say, a hyphen. Okay, good. So when we run this, we can now call for the row names as well and change it. the row names of empty data, empty-df, and we're going to and we're going to call we're going to name it backcross 1, backcross 2. Okay, so let's say bc. Okay, and then for that we have 1 to 10. The number of rows is 10. Okay, and we're going to include a separator, and that separator is also going to be a hyphen. Okay, it's also going to be a hyphen. So we're going to run this as well. Now when we call empty-df, you will notice that the right names have been allocated to it. So what if now we want to see, sample some genotypes and fill them? Okay, we want to sample some genotypes and fill them by column. Okay, that is our task. The next example is to sample genotypes, and those genotypes are going to be capital A, and then capital A, small a. Okay, these are the genotypes we're going. This is the data we're going to sample from. Okay, and fill by column. Okay, by column. Yeah. All right. So what we're going to do now is that we're going to use the for loop. The for loop is going to make it very easy. Okay, if we were to do this manually, once we sample our first data, we need to subset the first column and do that, right? Let me just explain what I just said. So we have our empty df. Okay, and let's say we want to fill the first column. So it means that we need to call the first column, right? If I should call the first column, I'm going to have this, right? Now I want to sample 10 genotypes and put that in that column. Okay, so I'm going to use the sample function, and I'm going to sample this data, which is capital A, and then capital A, small a, right? I'm going to sample this, and since I'm looking at the number of rows to be 10, I'm going to fix the size to 10. Okay, and the number of the size to 10. Yeah, and now since the data set is not much, we'll need to, or it's not many, we'll need to set replace to true, so that anytime a particular element is taken or sampled, it is then replaced. Okay, so now the moment I run this, okay, and I call empty df1, you will notice in empty df1 that the column 1 has been filled, isn't it? The column 1 has been filled with the genotypes. Okay, so if I need to do if I have, let's say, 1,000 columns, it will be cumbersome to index one after the other. It's going to be cumbersome to index one after the other. Okay, so the for loop is what we're going to use. Okay, so let's first check how many columns we have. We have 5 columns. Okay, we have 5 columns. So let's create an object called nco. Let's say nco1. Okay, and in nco1 we have 5 columns. Okay, good. Now let's go to the for loop. Let's use the for loop now. So for, I'm still going to go with my I. You can go with X, W, anything. Okay, so I'm going to go for I in seclen. Okay, I need to use seclen. Okay, because like I said, I'm dealing with a data frame, and I'm particularly concerned about columns and rows, and columns and rows have been indexed as 1, 2, 3, 4, 5. If in a particular data you're dealing with, the columns have, let's say, specific names, and you want to deal with just the specific names, you can go ahead. Okay, good. So I'm going to seclen, or I'm going to sequence numbers from 1 to 5. So I need to bring the number of columns we had. So nco 1, right? Good. Now in nco 1, we need to enter the block of code that is going to be repeated several times. Now since we just analyzed for 1, we can just copy that 1, come here, paste it here, and all we need to do is to just change this 1, this value 1 to I. Okay, so now when I just run this, it's done. When I call the empty df for us to view what is inside, let's say empty df for us to view what is inside, and I run, you could see that we have it's beautifully done. We have all our columns filled with genotypes. Okay, so I know it has been at a fast pace, but I would need you guys to sit down, okay, go through it bit by bit. If you do not understand anything, kindly leave it in the comment section, and we can talk about it. Okay, if you also need to mail me, let me just leave it here. Sorry. If you also need to mail me, you could mail me on Israel Tete 715 at gmail.com, and we could work things out. Okay, thank you very much for joining in this tutorial section. I hope it helped. uh, do your best to share, do your best to like, and also subscribe if you haven't subscribed yet. Thank you very much. Bye.